Assalamualaikum and good morning to everyone. How are you? I hope you guys are in great state and excited to learn more on FM. Okay, so as you know, today is already 23rd, and in about I think less than 2 weeks, you will have your first test, right, on the 3rd of December. And it's important, to remind you that your first test includes the topics included in your first test is from introduction, noise, AM, and FM. Okay. So hopefully we'll be able to finish our FM chapter this week. Okay. So last week, in our asynchronous class, we have done the earlier part of FM, right? Yeah, we learned about the general equation of angle modulation, which includes FM and PM. And then we learned about the modulation index, spectrum, and power performance. So these are some of the basic introduction to angle modulation, especially on FM. So I showed you a number of final year exam samples based on the first part. So before we continue with the generation of FM, I will just pick some of the questions that I shared with you last week to discuss. Okay, so let's look at this question. Okay, so this question is from last week, the first part. Okay, so you're given an FM spectrum. Okay, so if you look carefully at the spectrum, you have to be able to understand and distinguish the carrier and also the sidebands. So here, center is our carrier, and then it has 4 sidebands, and amplitude for all the components are given. And in question, it's also given the VCT, the carrier signal, which is equal to 20 cos omega CT. So from here, we know that EC is equal to 20. And we know that FC is equal to 80 megahertz from the spectrum. It's not given in the equation, but it's given in the spectrum. Okay, first, what is our modulation index? Okay, so the modulation index let's share the whiteboard first. Okay, so what is our modulation index? So from our spectrum, you can see that, okay, let's change the color. Okay, so from our spectrum, okay, the amplitude of our FC is given as 4.4. So the amplitude is actually E CJ naught, which is equal to 4.4. And then EC J1, amplitude of our first sideband is 11.6. Okay, so we just take note. Then EC J2 is equal to CJ2 7, 2.6 and 0.6. 7, 2.6 and 0.6. Okay, 7. 6, and finally is CJ4 equal to 0.6. Okay, so EC is given okay. So your EC is given as 20, yeah, from the VCT. So we can actually from all this information of our carrier and sidebands amplitude, we can find the modulation index from Bessel table. Okay, so here, what is the J naught? 4.4 divided by 20 is equal to 0.22. J1 equal to 11.6 divided by 20 is equal to 0.58. Okay, and up to J4, 0.6 divided by 20, which is 0.03. Okay, what you can do is to check the Bessel table. So table, what is the modulation index for J naught equal to 0.22, and then J1 equal to 0.58, then up to J4 equal to 0.03. And you can also check that you have this one carrier and n equal to 4 for sideband pairs. So if you remember from our previous examples in last week's class, these characteristics of n and j naught and all the amplitudes actually belongs to beta equal to 2. Okay, so from Bessel table, if you check, you'll get beta equal to 2. So this is our modulation index. The answer of our modulation index, beta equal to 2. You can get it directly from the spectrum. Okay, from spectrum, find out what are the J0, J1, and so on. Then check the Bessel table. So this is our first answer. Okay. Where's the whiteboard? Okay. And then time domain expression for the FM signal. Okay, the time domain expression for the FM signal. So you're given here, we know that beta is equal to 2, and time domain expression for our FM signal. Okay, so we remember the VFM equation. The okay, so here beta is equal to 2. So VFM is equal to EC cos omega CT plus beta sine omega MT. This is when we assume our BMT is in cosine. Okay, so this is our VFMT. So we already know our EC. We already know our FC, 80 megahertz. So we know already our beta. So what is our omega m here? What is our FM or omega m? So we can get it from where? Again, is from the spectrum. Okay, so we know that the gap between all these components is equal to Fm. From carrier to first sideband is Fm. From first sideband to second is Fm. Okay, so this is another Fm. So from here 80 to 80.048 we have 1, 2, 3, 4 4 Fm. So if you minus 80.048 divided by 40 divided by this the frequency maximum here minus our carrier's frequency and then divide by 4, we get our Fm is equal to 12 kilohertz, right? So it's 48 kilohertz divided by 4, 12. So Fm is 12 kilohertz. So we just put the value, or we have already all the values, we just put it inside the equation, substitute the values inside the equation. The EC, omega C, beta, and also omega M. Okay, so the maximum frequency deviation, delta F. Okay, so we know that beta is equal to delta F divided by Fm. Since we know already beta and Fm, we can find the delta F. So maximum instantaneous frequency. Okay, so Fi max is Fc plus delta F. So Fi instantaneous minimum is equal to Fc minus delta F. Okay. The time domain expression for the modulating signal given Kf equal to 8 pi kilorad per second per volt. Okay, so for this part, we know the general equation for Fm. Okay, so we'll show the whiteboard first. Okay, so beta sine omega mt is equal to, so beta sine omega mt is equal to sine 2 pi 12 kt, right? Okay, which is also this one equal to kf vmt dt, right? So from here, we are given our k f is 8 pi kilorad. Okay, so integrate vmt dt is equal to 2 sine divided by kf. Okay, just so our kf is equal to 8 pi kilorad. So in order to get vmt, we just differentiate, right? Okay, we differentiate this. Divided by Okay. So here you will get, okay, if you differentiate sign, you get cos, right? So it's cos 2 pi 12 kt. And then you multiply with differentiate the terms inside here. 2 pi 12k. Then this one divided by 4 pi k. Okay. And then, okay, we got our VMT is equal to 6 cos 2 pi 12 kt. So this is the time domain expression of our message signal. Okay. So next, okay, YFM is used for high quality sound broadcasting. So the main we know that main advantage of FM over AM is superiority to noise. Yeah. But and apart from that, okay, since the deviation for FM is quite large, then it can actually modulate large bandwidth signals, okay, compared to AM. So these are the two main advantages of FM. First, superiority to noise, and then it can transmit high bandwidth, high frequency sound signal. Okay, so let's move to the next. Okay, so for this question, you are given sine wave, amplitude 40, frequency 250 kilohertz. So it's frequency modulated using carrier wave 100 megahertz and amplitude 7 volt. Okay, and then you're given the frequency sensitivity in 3 kilohertz per volt. Write the expression of the FM signal. Okay, so here you need to use the general equation of FM signal. Okay, and then okay, so what's the expression again? VFM T equal to EC cos omega CT plus beta sine omega MT. Okay, so we're given the carrier and also the information signals, amplitude and frequencies. We just substitute inside here. Okay, for beta, we know that beta for FM is equal to KF EM divided by FM. So all the values are given. So should be able to find beta and put inside here. And then bandwidth using Carson's rules, we know that bandwidth is equal to 2 beta plus 1 FM. Calculate for bandwidth and modulation index, assuming the amplitude of the modulating signal is doubled. So here our EM is double. Okay, so new EM is equal to 2 times the old EM, which is times 40. Okay. So just repeat the calculation of bandwidth and modulation index. Okay, using this new EM. Okay, basically the steps should be similar. So these are the calculations for our basic concept on FM. Right. So if you have any questions, okay, you can drop your questions in Telegram, or at the end of your lesson, okay, you just post your question in the reflection. Okay, I'll respond to those questions. Right. So